This is Mr. Wild at creatortest.co.uk, and we are looking at the second part of a converting ratios to fractions question. So from part A we've found we have one box that contains in the ratio of 5 to 7 black to white counters. In the second box, box B, we have a ratio of 4 to 1 for black to white counters. Now we're told that each box contains the same number of counters. Okay, now there's several approaches to this, and I'm going to work you through at what I think is the most logical one, but I'll also show you a quicker way to do it after. So we'll start off by saying we're not sure how many counters are in each box. Now, as we have done with the previous question, if you've seen the work through for that, we've said, well, what's the minimum number of total counters we could have in the box? So the first box, we've got 5 and 7, so we've got 5 black and 7 white, is the lowest number of counters we could have. So if we have 12 counters, we have 5 black and 7 white. And we talked about how an equivalent ratio up here of 10 to 14 will be another possibility for the number of counters we had. Now over at the other side then, we've got 4 black and 1 white, so the minimum possible counters we could have is 5. Now we've got a problem here, because it says they've got the same number of counters in each box, but if we use the lowest possible number of counters that the ratios say we could have in a box, we'd have 5 and 12. And we don't have there the same number of counters in each box. So what we're going to do is we're going to use equivalent fractions to ensure that we do have the same number of counters in each box. So a possibility for the box A, which is here, is we could have 10 to 14. And that would be an equivalent ratio of 5 to 7, which would give us 24 counters. We could keep on doing this, and we could say 15 to 21, which is 3 times the original ratio, and is still equivalent. And we could keep on going like this, and what you'll find is down the left hand side here, we are writing out factors of 12. Oh, sorry, multiples of 12. Okay. On the second ratio, we could do the same and write out equivalent fractions for 4 to 1. So 8 to 2 is exactly the same as 4 to 1. We also could say that 12 to 3 is the same as 12 to 1, and 16 to 4 is the same as 4 to 1. Now if we put the numbers down the side here, we'll get there's 10 counters there, there's 8 black and there are 2 white. We've got 15 counters here and we've got 20 counters in, and what we're writing out here are multiples of 5. So if we keep on going, multiples of 5, 25, 30, etc, etc. Now if we want to have the same number of counters in each box, we're going to actually have to find what we call the lowest common multiple of these two numbers. Now if you haven't realised already, multiples of 5 will lead us eventually to 60. And no number before 60 is a multiple of both 5 and 12. Now if there were 60 counters, let's think how many there'd be in each box. So if you had a ratio of 5 to 7, the equivalent fraction, well, this is twice as big as the original, this is 3 times as big as the original, this would be 4 times as big as the original, this is going to be 5 times as big as the original. So 5 times 5 gives us 25, 5 times 7 gives us 35. So this is an equivalent fraction to 5 to 7, but now we have a box with 60 counters. Now if we do the same on the other side, and we think about how would you get from 5 to 60, well, if we had 5 counters and we want to get 60, we'd have to do times by 12. So down here, we're going to have to times the ratios by 12 to get an equivalent ratio of 48 to 12. And we've got an equivalent ratio. So let's see where we're up to them. We've got one bag with 25 black and 35 white. That's bag A. We've got another bag with 48 black and 12 white. And in total, if we now combine the bags, because they have same number of counters, we can find out that in total, well, here we have 60, 73, and here we have 47. So we have 73 black and 47 white, out of a total of, well, we've got 60 in one bag and 60 in another, out of a total of 120. So it's a long way of getting there, but what fraction then are black? Well, we said there's 73 blacks altogether out of a total of 120 counters. Okay, so that question I thought was quite difficult. There's a different way to do it, and I'll show you that very quickly, but I think the logical way would be to look at this tutorial again and look at that way of doing it, because it makes more sense to me. You've got 2 bags, you make sure they have the same number of counters in there, then you see what fraction is black and you can also find out very quickly then what fraction are white. The other way we do it is we've already worked out from the previous question that in bag A, 5/12 of the counters are actually black. In the second box, it's 4 counters out of a total of 5 are black. And what we can actually do is add these 2 fractions together, which, if you do, you'd probably use equivalent fractions, similar to how we use equivalent ratios, and you use a common denominator, which amazingly turns out to be 60. If anyone can see the relationship here between the two, and 5/12 is exactly the same as 25/60. Again, you might recognise that 25 number from somewhere. 4/5 can be turned into 48/60, and again you might recognise that number from somewhere. And if we add them 2 together, we end up with 60 73/60, which seems a bit ridiculous. Why isn't it 73 120ths? But you've got to remember, we're combining 2 bags there. So what do we need to do to that number? Well, we need to divide it by 2. And if we divide it by 2, that's the same as timesing by the reciprocal of 2. And if people know what the reciprocal of 2 is already, it's the same as timesing by a half. Dividing by 2 is the same as timesing by a half. And when you times fractions, you times top by top and bottom by bottom. That's numerator by numerator, denominator by denominator. And you end up with the same result, 73/120. So there you go.